The magnetic field that comes out of the sun has more than doubled over the last 100 years. As a result, fewer cosmic rays have sprayed the atmosphere and fewer clouds has formed. The consequence has been a warmer Earth. When a strong magnetic field comes out of the sun, fewer cosmic rays spray the Earth. That means fewer clouds to keep us cool. But a lazy sun with a weak magnetic field lets in more cosmic rays from the stars. And in the air, they make more clouds. That's how the stars and the sun controls the Earth's cloudiness.
The suggestion was made by Svensmark in Denmark that this effect of cosmic rays is really important. And he based that on the remarkable correlation between worldwide cloud cover and the cosmic ray intensity. The magnitude of the effect, if his speculations are correct, would suggest that that is as powerful effect as the present greenhouse effect or the brightness variations of the sun. It remains to be seen now, of course, as to whether that effect is valid, but it is a major contributor to this whole process that needs to be investigated very carefully.
This idea with the cosmic ray modulation of the cloud cover is probably the most interesting mechanism today. If that was a building, and what is found in this research results from Denmark is that there's a very good correlation between clouds and the cosmic ray modulation, which we have measured for 50 years almost. But this shows that it's the sun's magnetic field that's very important for how the sun appears, and that's very important to understand one cycle, and then we can go back and try to understand how the sun has changed on the long term. We know now that the sun's magnetic field have increased, and we know the sun is more and more active. The activity has been increasing the last 100 years by a factor of 2. If Svensmark's work is confirmed that he's right about this idea, I think it will have big effect on the whole climate discussion, because the clouds are so effective in changing the climate or trapping or closing out radiation. It's now important to do the research to try to understand this mechanism. And so I think we should take this very seriously and try to understand this mechanism.
When we presented our results in Birmingham in 1996, we were of course very excited to present the results, but much to our surprise, it was received very, very negative. And the only thing we had done was to present a scientific result which showed that the sun through the clouds might be very, very important for climate.
There was, of course, a reaction also from the International Panel on Climate Change, the UN panel. Bert Bolin, who was the scientific chair at that time, he thought it was irresponsible of us to say that something else than the CO2 could be the main driver for climate.
So there's no doubt that the sun has an effect on climate. The whole climate community really hated the idea that the sun should have a major impact on climate. That was seen as a disaster. I was actually shocked about the responses that we got. During the last 25 years, CO2 has been the dominating theory trying to explain all climate variation. However, if we look at historical climate, there's absolutely no doubt that the sun has been extremely important and you cannot ignore it.
We're at the Dead Sea, and we're going to a place called Nahal Pratzim, which is one of the nicest places where you can see climate variations taking place here. People have this conception that the sun is this constant ball of gas that doesn't do anything. This is wrong. In reality, the sun can sometimes be very active. It's this solar activity, this dynamic nature of the solar activity, which affects the solar winds and which affects the cosmic rays and which eventually affects climate here on Earth. Climate variations over the past decades, centuries, millennia can be reconstructed from many different places around the world. Here we're now located in the Dead Sea. 20,000 years ago, the Dead Sea was higher, it was much wetter, and the level was higher than where we are standing. And every year there were yearly deposits which were left on the lake's floor. And here we can see those annual deposits. Basically, during winter, the dark deposits are left, and during summer, the bright deposits are left. So the ratio between the dark and the white bands tells us a climatic story. It tells us how the climate here varied during the years. On these timescales of centuries and millennia, you can reconstruct what the sun was doing using cosmogenic isotopes like carbon-14. What's interesting is that this carbon-14 is directly formed by the cosmic rays. So this and other results or other measurements from around the world tells us that the sun is affecting the climate. This link between solar activity and climate on Earth, it's not hypothetical. You just see it in the records. When the sun was more active, you indeed see that it was warmer on Earth, and vice versa. "300 years ago, for example, the sun was not very active, and we were in the height of the Little Ice Age when it was cold in many places on Earth. 1,000 years ago, the sun was active. It was as active as it is today, and it was warm everywhere. The Vikings could map all of Greenland because the northern shores of Greenland were not frozen. Most of the people today think that most of the climate change is because of CO2, but this is wrong. Most of the warming over the 20th century is because of the sun.
If we look at Earth from space, we will see that about 60 to 70% is covered by clouds. If more cosmic rays comes down, we will have slightly more clouds. And you can imagine the opposite, fewer cosmic rays, we have a little fewer clouds. Instead of thinking of clouds as a result of climate, it's actually showing that the climate is a result of the clouds, because the clouds take their orders from the stars.